Today we're going to be talking about using our calculators to figure out the Riemann sums. So we're going to have more than 4 intervals. I recommend you use your calculator if you have more than 4 intervals. Okay. Remember that each one of these rectangles is a width, which we know is delta x, which we get by doing b minus a over n, times by some height. The height is a bunch of function values. So, say for this first rectangle, we're finding the width, which is delta x, times by f of x sub 0. Our next rectangle, we add to it the width times by f sub 1. So the next one. And then we keep going. Delta x times by f of x sub 2. All the way to our last one, which is x times f of, in this case, x sub 6. Now, there's a reason that I always pulled out in the last video the delta x. The delta x can get factored out, and then you have, let me extend my page here, f of x sub 0 plus f of x sub 1 plus all the way through to f of x sub 6. So I factored out that delta x, and then you're adding together all of these different function values. And today we're going to be using our calculator, so we're going to have like 50 of these. We're going to start with 10, we're going to do 50, and then we're going to do 100. So you're going to have a lot of these different function values that you're going to be adding together. What this is this is a sequence that we're going to be using, or we're going to be using sigma notation. Okay, so this is an important slide. So our area is the length times the height. We just talked about that. Length is b minus a over n, also known as delta x. I've started to talk about that. Now the height is the sum of a sequence. This is how we do sigma notation in your calculator. You start by plugging in the function, the variable you're taking, the variable with respect to that function, the starting endpoint, remember it's different for left, right, and midpoints. The ending value, this is your, you can kind of look at that as your A and kind of your B, but it's going to have to deal with the delta x, and then the length of the rectangle. I should say length of the rectangle. I've been using width actually this year, which is delta x. So your total area, again, remember, is your delta x times by this sum of a sequence of all this stuff from up here. Okay, left endpoint. Your length is always delta x. Remember, left endpoint, you're starting at the leftmost point, so you're starting at A. Your endpoint is b minus delta x, because I don't end at b. I'm doing the left endpoint of that left endpoint of that last rectangle, so that's how we get that. Right endpoint, you go over your delta x, so you do a plus your delta x. Your endpoint is b, and still you're at delta x. Midpoint, a, now you go to half of your interval. And then for your ending point, you're going to half of your interval. And then your length is still delta x, because your width of your total rectangle is still delta x. Okay, so first example. Estimate the area under the curve using 10 equal subintervals, right endpoint, left endpoint, and midpoint. And I'm going to show you guys how to type this in your calculator and the interval from 1 to 4. Okay, so this is your function. Your delta x is 4b minus a over the number of rectangles that works out to be 0.3. So for our right, which I do first, just because it was listed first. Okay, you have your delta x. Don't forget that. I often forget that. So your delta x, that's what this is. And you multiply that to the summing up of all of your rectangles, all of the heights of the rectangles. So that's a sum of a sequence, and this is what the calculator notation is going to be. Your function, 2 over x, left rectangles. So I have this drawn in here just so I can visualize it. Left rectangles, I start here. Now, yes, I know this is bigger than what my delta x is, but I just like to have a visual in my head so I know I start at A. So I don't have to memorize that chart. I apologize. These are right rectangles. So I'm looking at that the wrong way. The right rectangles, this is going to be my right rectangle. So for my right rectangle, I have my A. To get my height, I have to go over delta x. So that's 1.3, 1 plus your delta x. You're ending at your endpoint, 0.3. I don't know why I wanted to add a 0 in there. Okay, and I'm going to show you guys in a minute how to do that on your calculator. For the left, again, we have our delta x. I'm struggling today. Delta x, which is 0.3 times by the sum of a sequence of 2 over x. Now remember your left endpoint, you start at A, so 1. Your last rectangle starts here and goes over. So it's delta x less than what your B is, so that's 3.7. And we go up in an interval by 0.3. Now for the midpoint, your delta x is still 0.3. We do the sum of a sequence of your function x. Now we go to the midpoint of your interval. So yes, it's not to scale on my graph here, but if this is my whole delta x, I go to the midpoint to get my rectangle. So A plus half of delta x. And then your last rectangle, okay, let's say that this is your delta x. You're going to your midpoint to get your height. So that is your B minus your delta x. Now I'm going to show you how to type that in your calculator. So I'm going to be showing you how to type in the sum sequence into your calculator. The first one I'm going to do is the right. The first thing you need to remember, don't forget to type in your delta x. Type that in first. I often forget to type in the delta x. Don't forget to do that. Now there's really two types of calculators out there. There's the older version that I'm going to show you first, and then I'll show you how to do it with the newer version of the calculator. So the older version, this is what you're going to do. You're going to go second stat, we're just going to bring up the list, arrow over to math. We want to do a sum, so number 5, of a sequence. So again, second stat, now ops, OPS. So sum of a sequence. First, you type in the function. Then the variable that you want to find the sequence with respect to. And then your starting point, I'm doing the right endpoint first. The ending point. And then what your delta x, what you want to go up by, this step they call it. So 0.3. So I just want to make sure I type that in right. That's my delta x out in front that I'm going to need to multiply all of my function values by. Sum sequence function x, starting point, ending point, what you want it to go up by, and that's what you get. Now I'm going to show you if you have one of the updated versions of the calculator with the left Riemann sum. And I actually really like this a lot better. It inputs all of this stuff here for you. So 0.3, remember that's your delta x. You still have to go into your second stat, arrow over to math, and again you want to do number 5. And then arrow over to up, sum of a sequence. Now it brings up this screen. Expression, the equation. So we're looking for 2 divided by x. The variable, x. I'm going to do the left endpoint with this one, so I'm starting at 1. We're ending at 3.7. The step, which is 0.3. Now this is going to paste this automatically in there. That's why I kind of like that one a little bit more. Apologize for those of you that don't have the updated calculator. I'm not going to lie. Google how to update your calculator. It's going to make your life a lot easier. And press enter. Woohoo, and that's what I got when I did it earlier. Now I'm going to do the midpoint for you guys. It's really easy with this updated version. Okay, so we go into... We want to do the sum of a sequence. Again, this is all in the list menu. But what I want to show you guys is it's really nice now. They have the function saved in there, so I can just press enter, enter. You just have to change your starting, and then you have to change your ending. Your step is still 0.3. So that makes your life so much easier. And again, that's what I got when I did it. So that's how you use your calculator both ways. Hopefully that made sense for you. Okay, now that we've typed that in our calculator, we get 2.562, 3.012, and 2.766. That's all I have for today. Please make sure the lesson summary, which is below this video, is submitted on time.